Hi folks, welcome to 7.5 part 1. In this video, we're going to talk about solving trigonometric equations, and as usual, we'll start with what we know. All right, so we are pretty much done with chapter 7, and in this chapter, we've learned a lot of things, including verifying trig identities using all of these identities, but more importantly, really working on our algebra skills. We've learned to evaluate using sum and differences of the main trig functions, and then also evaluating exact value of double and half angles. And so what's new? In this section, we're going to take a look at solving equations with identities, algebra, and inverse trigonometry. So we're really putting together the chapters 5 and 6 to help us solve equations now. And in particular, we're going to look for two types of equations, two types of solutions. We're going to look for finding solutions over a given interval, that is just one time around the unit circle. And we're going to look at general solutions, meaning any amount of times around the unit circle that we want. Okay. All right. So the way this lesson is going to be structured, we're going to take a look at the first type of trig equation. I like to call these linear equations. And they're really going to build off of our algebra skills on how to solve linear equations, all right? And so some of these examples are going to be trigonometry, and some of them are actually going to be with algebra, just to make sure that we're really brushing up on all the different skills. And even though we have more letters here, we can see that really they're the same kind of equation, okay? So let's get started. All right, we're going to take a look at example 1. It says sine x equals -1. And after that, we'll take a look at example 2, where cosine x is 1/2. And so the thing with these two is these are going to be pretty straightforward equations, but we're going to use them to help us understand what it means to have a solution over this interval 0 to 2 pi, and then what it means to have a general solution. Okay, so we're really exploring those concepts here. All right, so let's get started. We've got sine x equals -1. And so what this really means, we have sine x equals -1. It really means we're looking for all of the angles that have a y value of -1 on the unit circle, okay? So look for all angles on unit circle with a y value of -1, okay? And we're only going to look one time around the unit circle. And so I'm going to draw us a little picture here. If we think about our unit circle, right, we've got something kind of like this. And the only place where we have a y value of -1 is going to be right there, okay? So that means that this equation actually only has one solution over the interval 0 to 2 pi. And in fact, our solution will be at 3 pi over 2. Okay. Remember, we're using mostly radians, like 99% of the time we're using radians. So we really want to say 3 pi over 2, not 270 degrees, okay? So that's what it means to be a solution over the interval 0 to 2 pi. But remember, we also want to learn this new term, general solution. And so general solutions means that if we grab our picture from over here, and we sort of copy it over here, just so we know. General solutions means what are all the different possible names for this point, right? Meaning I could say it's 3 pi over 2. But I could go around the unit circle again. That's also a solution. Or I could count in the negative direction, a negative pi over 2. That would also be a solution. Or I could go 1 and a little bit times around in the negative direction. That would also be a solution. And so since we have really an infinite number of solutions, what we want to say is this. X equals 3 pi over 2. Okay, so that's where it is. Plus as many times around the unit circle as we want. And we know that one time around the unit circle is 2 pi. So we're going to say plus 2 pi k. Now, what is k? Why am I throwing in new letters? Well, k is an integer. Okay, so these symbols that I wrote right here really say k is an integer. Now that means that k could be 1, 2, 3, 5, 100, but it could also be like -1, -2. So what that means is I'm going to go to here, and then if k is like a positive 1, that means that I would go one more time around the unit circle, and I land in the same place. Okay. Same thing, let's say k was -1. So I'm at 3 pi over 2. If I go negative, I'm 1 or times 2 pi, I'm going to get back to where I started. Okay. So this fancy thing is really saying times around unit circle. Okay. And so part of this math that we're doing is, sure, we want to learn the math, but we also want to be able to read it and write it in a way that other people do so we can understand. Okay. All right. So example 1 looks like that. Example 2, let's take a look at example 2. Looks very similar, but instead of sine equals -1, we have cosine x equals 1/2. So let's think about what that means. Cosine x equals 1/2. That means look for angles with x value of 1/2. All right, now this time I'm looking for an x value because I have the cosine. All right, and in particular, I want to see where we have an x value of 1/2 on the unit circle. So let's grab our diagram from earlier. Let's see if I can erase just that blue point. Nope. There we go. All right, now, where are the angles that have an x value of 1/2? Well, it turns out if we look at our unit circle, we've got one here that happens to be pi over 6. And then there's another place where we have an x value of 1/2. Oops, sorry, x value of 1/2, not y value. X value of 1/2, I'm sorry, is pi over 3. The other place it happens is at 5 pi over 3. Okay, so this time there's actually 2 solutions. And so instead of just writing x equals 3 pi over 2, we're going to write x equals pi over 3 and 5 pi over 3. All right, so those would be my solutions over this interval. Solutions just one time around the unit circle. Now, let's use this diagram to talk about our general solutions, okay? And it turns out that we actually have to write this as 2 separate statements. We're going to write x can equal pi over 3 plus as many times around the unit circle as we want, as long as k is an integer. And so that takes care of the first one, but then we need to do the same thing with the second one. X equals 5 pi over 3 plus 2 pi k, where k is an integer. Okay, so let's get this all on one screen for us here. These are two examples of finding solutions over a certain interval as well as general solutions, right? Now, we're going to do one more here before we end this part one of the video, okay? And that's going to be example 3, right? And so in example 3, we'll notice that we don't have sine or cosine, but we actually have cosecant. And I know that sometimes when it's sine or cosine, we already get nervous enough, but then cosecant makes us more nervous, okay? So let me show you how I would approach a question like this. I know that cosecant and sine are reciprocal functions, right? So that means that cosecant x is equal to 1 over sine x, and sine x is equal to 1 over cosecant x, all right? That's what it means to be a reciprocal. So cosecant x equals -2 is really the same thing as saying sine x. So I took the reciprocal of that side equals the reciprocal of the other side. Okay, now I don't change the sign. It doesn't become a positive 1/2. All I do is I take 2 over 1 and I flip that number. That's where I get that 1 over 2 from. Okay. Now this, I think, is a lot easier for us to look for on the unit circle. So we're gonna look for, angles with y equals -1/2. That's what we're looking for, okay? So let's get a diagram here. Whoop. Let's get a diagram here. Right. And let's think about where the y values could be -1/2. And there should be one right here and one right here. And if we look at our unit circle, this should be 7 pi over 6, and this one should be 11 pi over 6. Okay, so what that means is that x will equal 7 pi over 6 and 11 pi over 6 when we just look one time around the unit circle. But we still have to find our general solutions. So let's go ahead and copy that diagram over there. Now, just like the other one, in example 2, I had to write them as two separate statements. We're going to do the same thing here. Oops. X equals 7 pi over 6 plus as many times around the unit circle that I want, as long as k is an integer, and x will equal 11 pi over 6 plus as many times around the unit circle as long as k is an integer. All right, so that, my friends, will conclude part 1 of this video. We've looked at some of the most basic solving equations. In the next one, we're going to beef it up a little bit and see what else we can do with linear equations.